Good evening, everyone. This is the last session. So just looking at the faces, how we make everyone engaged, right? Yeah, by the way, I'm Kannan from PalC Networks. This is Kashi. So we have been working with multiple customers to adapt SONiC. So basically we are system integrators who are bridging customer who wants to adapt SONiC or thinking about SONiC, and working with the complete overall open networking ecosystem, be it open hardware or open NOS like SONiC and SFPs and the whole open source tools, right? So we understand the complete full stack and make sure that the customers adapting it and making it successful. So we support them in design, deploy, and manage their network. That is our role as a system integrator. To introduce PalC, PalC was started about 8 years ago. We have been working with multiple networking companies in control plane protocols and support ecosystem. So we understand the whole ecosystem when the moment SONiC is coming in. So there are a lot more queries which is popping up, right? Hope you remember when 15-20 years back when we were asked to use Linux, right? When as a user, as a customer, you are going to use Linux, moving away from traditional or proprietary OS into a open source OS, right? So you would have had a lot of apprehensions about it, right? How we can use it. Anybody can remember what was your thought process when if somebody or your manager told you to use Linux-based server, Linux-based system, right? So I was asked. So you, as a user, you had a lot of queries, right? Whether everything will I be productive, right? That's the first thing that we talk about, right? So now it's kind of a Linux moment for switches and routers, right? So 20 years back we adapted Linux for desktops and servers. So when the SONiC is trying to take the place of Linux for switches and routers, as a customer, right, there are a lot of queries are coming up, right? Since we are the single point of contact for customer working with open network ODMs and SONiC community and the merchant silicon like Broadcom and multiple customers, right? So I want 10 features, right? So how we are going to make sure that how we are giving a confidence to the customer, making sure that they are successful. It works seamlessly, right? Like it's as if when you join a new company, right, you have to adjust, right? The SONiC also need to adapt, right? There is already incumbent switches and routers are there. So as a customer, I'm more concerned about it, how it will work, interwork, because SONiC is it's being used for greenfield as well as brownfield as well, right? So there are questions about interoperability and how my application work, how application performance, how my protocol works, right? So there are queries that we are getting it, right? So one of the main thing is about network monitoring, right? So I'm monitoring in a certain way, and now how SONiC can help me to monitor better perspective, right? So today we are going to take up one particular use cases where we built a network monitoring solution on top of SONiC ecosystem for our customer, how we are solving it, right? Yeah, so just to put everybody into perspective, right? So as a customer, as a user, right, we think in a different perspective, but when you are designing a network, right, it's like as if you are designing a city. If you are designing a city, then your switches and routers are junctions, your cables are roads, right? And the cars are on the road, right? So like take Bangalore, Hyderabad, Chennai, it's completely different because it's designed differently, right? And have we given enough authority to the traffic police or traffic controller to visible how many trucks are going, how many red color cars are going, how many cars are actually making jams, or how many actually causing the accident, right? So there are typical things are happening. Similarly, when a customer is designing a network, right, there are 7, or at least we have put it at least 7 dimensional issues where how my network design, will it be compatible with existing ecosystem, and I have certain application, right? When I bring in SONiC, how does it work, right? And how are you going to integrate with my open source tools? I have set of tools. How are you going to integrate? How do I make it work, right? That's the first thing. And anyway, I have problems. I have to adapt multi-vendor for whatever the cost and other factors, right? And now how Linux or Android opened up a new set of horizontal innovation, right? Anybody can write application and you can run it, right? How Android and Linux there. So when the multi-vendor comes in, it opens up a different set of innovation, right? So they want to build their own applications. How my proprietary application, which is specific to me, how does it work if SONiC comes in, right? So these are all the common question, and about the high availability and security aspects of it. It's an open source. How are you going to commit to it, right? So we are listening to them and understand and work with open networking ecosystem, be it ODM vendors or merchant silicon, and we have been understanding all the features and trying to map, hey, this is how it should work, and we kind of co-create design and work on the deployment part and then go for a support thing, right? Like now, if I bought a laptop from somebody, right? So I can go and ask them, hey, it's not working, right? You can hold that particular person accountable, even your Microsoft Word is not working, right? Because he's responsible, right? It could be anything. But if I am using open hardware and open NOS, open source application, on top of that, as a customer, I am running my own application, right? Whom are we make accountable? As a system integrator, we take accountability of understanding the system, how it can be migrated, how it can be solved, right? It could be a problem in anywhere, the layer, right? It can be optics, it could be protocol, or it could be NOS, or it could be hardware, or it could be fan is not working. There are multiple things that we understand and plan it ahead. So we kind of looking at if a system or roads are designed well, there won't be any operational issues, right? So that's how we typically see it. So the operational challenges, also the customers are looking at, my operation should be smooth so that the design should be proper whenever we bring in or revamping the network or building a new network because of AI, right? So one of the things that we are looking at is the operational challenges. The customers are keep repeating multiple things about how do I upgrade, how do I debug, troubleshoot. Certain things are manual things. How are you going to integrate? The observability is one thing, right? And multi-vendor, I have multiple ecosystem, multiple NOS I am using. How are you going to make sure that things are working as expected in terms of a latency or application performance, right? Everything comes into the picture. So these are all the talking points which we listen and see how it can be addressed, all of them or some of them, or some of the things that can be managed somehow, right? So that's when we bring in our expertise here. So what we are seeing one particular issue is, right, when you can see things properly, you get a confidence, right? So we look at monitoring is the one thing which should be put as the center of the solution and build your network, right? So then things will be much easier. Okay, I can manage, I can see how many packets are flowing, why is it happening. If I have a visibility on the whole ecosystem, I'm more confident, right? Let's say I have a phone, right? If my memory is out of, my memory is just reaching beyond some limit, you are confident that, okay, I have a system which tells me that I am visible, right? And how much data I have used. So the phone gives me confidence so that you can manage your network better, right? Something similar customers are looking at, the mainly monitoring perspective, right? If you are talking about 400 gig, 800 gig, the bandwidths are exploding, right? So the current network, right, which has different set of monitoring tools are available. I want to see the entire network traffic without impacting the, let's say I have 100 gig traffic, right? I want to see all of them. I want to tap out only TCP. I want to see who is just hogging up 50% of my bandwidth, or somebody is causing congestion, right? So all these visibilities are visible, right? It will be much easier for me to manage, okay, this is how I can contain the congestion, or I can manage, or which is causing the drop, right? So there are current setup, there are multiple hardware boxes are available which would kind of support And the main thing is about I have multiple tools which I am monitoring for different purposes. How we can have a single pane of glass, right, to view it. And there are features like if I have any vendor, if you take it, I can tap 2 ports and I can monitor, right? I can sniff it and I can see it, right? So now, but if I have a closed box, then I am limited by the features provided by particular box, right? That particular box might give you only L2 level, L3 level, L4 level, right? So now what we have built is for one of our customers, we leveraged SONiC and we built entire monitoring application on top of SONiC, so that the open hardware can be merged with SONiC and you can build your own network monitoring applications, which could be utilized for any sort of security or any other application that you can have proprietary open source tool that can be leveraged, right? So these are all the customer typically have problems when I have a monitoring, right? So what we are looking at is to provide a customers, it's like a spectacles, right? If I have spectacles, I can see things better. I am more productive, right? The spectacle is just not a lens, right? It makes me more productive, right? So we want to make sure that the observability, the better visibility gives a better throughput and better operational efficiency for our customers, right? So what we are thinking about overall strategically, the observability is the one thing which will help more SONiC adoption because I can see things what's happening. And also this helps to end-to-end support. And as a system integrator, we are bridging the customer who wants to adapt for thinking about SONiC and connecting with the whole ecosystem, right? So we are bridging it and the vendor neutral parts, what we are looking at is the open hardware with SONiC. People can write on top of their own applications or monitoring. That will be the best thing to do, right? So what Kashi is going to talk about is how we built the overall architecture. He'll go deep and explain how things are working currently, how SONiC is helping us to monitor better for our customer and so that they can reach out to end customers, right? And that's one part of it. The other part of is how it can be scaled for multiple applications, how it opens up for innovation, or how people can look at visibility as a one aspect can be leveraged for better troubleshooting or faster deployment, right? That's one thing. Probably with this note, I'll hand over to Kashi to go deep on this.
Yeah. Okay, so this is just a simplified architectural diagram. So at the bottom, you have the physical data center or a service provider network. We would probably use physical tap devices to get a copy of the live traffic and send it to something called a packet maestro, which is the name of our customer E.C.I Networks, their product, which is internally running a disaggregated packet broker, which is running SONiC. Packet Maestro Pro is nothing but a suite of analyzer tools and analytic tools, which gives deeper analytics and deeper insights into all the packets which the disaggregated packet broker is going to give us. So I'll just move to the next deeper slide. So as discussed, we have the physical tap devices, which would give a copy of the live traffic from anywhere in the network, wherever you want to see how the traffic is traversing between two nodes or between the entire data center. And then we pass on that copy of traffic to a disaggregated packet broker, which is nothing but a containerized application which is running in SONiC. So since SONiC is open in a modular NOS system, which is container aware, we created a small application which uses and leverages all the other protocols and features with SONiC and built this application. And this gives us a core set of features: traffic aggregation and reassembly, load balancing to the upper layers. You can also do multiple filters for different types of packet permission and dropping them. So we also can do VLAN tagging and untagging. We support IPv4 and IPv6 traffic rules. And this being on top of open hardware gives us other benefits, which I'll cover in the next slide. So on top you have the Packet Maestro Pro, which is nothing but a suite of tools which are having high density ports. Over here we have feature sets like deduplication, because you have the same type of traffic coming via different tap devices. You can have time stamping, you can have packet trimming and splicing to reduce the load on the network. You can also have burst protection for bursty type of traffic. Now there are certain other advantages of using wherein, like for example, load balancing. If you see a protocol analyzer, we have 3 ports connected, all of 25 gig. We could create a port channel over there and load balance it over there. So moving on. So a little deeper into this architecture of our disaggregated packet broker. It's based out of community SONiC, as just mentioned. We have, because we've leveraged the open and container based architecture here. The other important aspect is decoupling the hardware and the software layer. So thereby any organization would need to have an initial investment of hardware, and then the software can be upgraded as and when needed. So the unique value proposition for this is choose your own hardware, so there's no vendor lock-in. The open hardware should have a couple of prerequisites, which should be only preloaded, thereby allowing upgrade of SONiC in future, and OCP hardware compliance for interworking with other certified vendors. So not only can the disaggregated packet broker have just that application, it can also be used for any other use cases which the particular end customer might need, that thereby making it truly multi-purpose. And as of the latest release, we have also added pay-as-you-grow options, wherein we have brought in port-based licensing, and that would give the end users an idea of how the monitoring solution is built, and as they scale out, they can increase their. So some of the key advantages is we have the ability to reuse this open hardware for different software, and since it's a modular network and modular system, you can have other applications running on the same hardware. This gives us long-term flexibility, vendor independence, and cost-effective upgrades spread over a long duration of this thing. So building this disaggregated packet broker over SONiC makes it a smart investment option and not just a basic technical decision. So I'll just touch upon some of the key features in Packet Maestro Pro. So we have, it is our advanced data processing solution provided by E.C.I Networks. They have a suite of tools which do deduplication, slicing, reassembly, data masking, and each of them for different types of use cases: data masking for compliance and security, advanced filtering and custom filtering for fine-grained traffic control, in-depth analysis, deep packet inspection, and you could have a data export of the S-flow to a Grafana dashboard. They also have tunnel management tools where they can check or they can do GTP termination, VXLAN termination for different use cases in service provider networks or in data center. You have visibility intelligence in your 4G and 5G networks, separate tools which does EPC, signaling, data tagging to identify why a particular set of call drops is happening over a particular type of network. And the added advantage is being an open network, the hardware can be decided which provide high density ports for the different types of applications. So there might be some wherein you want to have a copy of the entire data traffic, which could be a 100 gig port, whereas others you could have maybe 10 gig or 25 gig. So we have a short demo which just shows the UI of our NMS of the DPB. Here we show the drag drop functionality and how we are adding rules and maps. Finally, we'll just touch upon what are the features of Packet Maestro Pro. Can you play it?
Welcome to NMS, a centralized management system built for SONiC-based disaggregated packet broker. It simplifies network operations by combining configuration, monitoring, security, and traffic engineering in one platform. The main highlight here is the traffic control part, and this is the core strength of the NMS. Let me move into dashboard and show you the drag and drop of the packet broker interface. Using SONiC container-based architecture, the DPB performs 3 key functions in one place, which is aggregation, where multiple streams of data from multiple links forwarded to the specific tools. And here we can simplify, see the statistics of the incoming and outgoing ports, and also the matched traffic, the rule-based statistics information as well. And the second part is the filtering, strips out only the relevant traffic, let's say IP-based, port, protocol-based, port-based, and that is forwarded to the specific tools, so that the load is reduced. And there is one more thing is replication part, where it makes multiple copies of the critical traffic, and the final part is the load balancing one, where it evenly distributes a traffic to the multiple ports. And from the multiple tools port, we can connect to the IDS or performance monitoring and forensic tools. Let me show the usage of the drag and drop. Let me take one Ethernet and one port channel, connect to it, and let's assign a map ID. And yeah, so by this, the incoming traffic from the 43 Ethernet is based on the filtering criteria. It will filter and forward to the port channel, which is the members are 73 and 69. Yeah. This is regarding the DPB. And moving on to the NMS side, right? We have manual device onboarding, where we can add SONiC or Packet Maestro Pro devices in one go, and we have topology viewer, where the NMS provides a clear topology view, giving operators instant visibilities of their network. We have monitoring part, where we schedule, we poll the system informations, telemetry, the CPU, the port informations periodically, and also we have historical graphs based on the CPU usage, memory usage, and thermal. And we have SNMP related things and the user logs, and we can have the license upgrading, the firmware upgrading part in the SONiC. And we also have a configuration management, where operators can configure SONiC modules directly from NMS without relying on the CLI. And regarding the application, we have RBAC, and we have HTTPS connection, and we can give one click to the particular console of the device, where we have ISCLI supported. And in short, NMS empowers SONiC-based DPP deployments with visibility, configuration, security, and simplifies traffic engineering, while also support Packet Maestro Pro, which is a high-performance network operating system optimized for Marvel processors, designed for secure, accelerated, and intelligent traffic handling with deep packet inspection, traffic steering, and acceleration. Thank you.
Thank you. So I just want to finish it off by sharing a success story of a deployment done by E.C.I, and we helped in the deployment. So DR Middle East is an ICT solutions provider with 2,500 professionals, and they're in these areas of infrastructure projects. They had a challenge where they were facing surging digital traffic. They couldn't comply with the regulatory compliance and security issues. So they needed enhanced monitoring, they needed secure traffic monitoring and data integrity without disrupting operations. So one of the key challenges and key idea of this disaggregated packet broker is that it falls in the OOB setup. So we are not part of the line traffic, and all the physical taps are the ones which take the traffic and send it to us. So They deployed this solution and improved the traffic management. They achieved lower TCO because of open and flexible design. They improved network efficiency because of the advanced filtering and load balancing which we provided. They are future ready. Most importantly, they are now able to comply with their regulatory requirements, and we ensured smooth deployment without any disruption. So this is the final testimonial which was given by this thing. So that's it from us. If you have any questions, please shoot.
Anybody has a question? Great talk, by the way. Okay. If no question, nobody has a question. Thanks a lot for the
Thank
great
you.
talk.
Thank you.
You have a question? Yeah.
Packet inspection at line rate, what is the CPU?
No, see, so that's the best part of it. Packet broker, which is where SONiC is running, does not do DPI. DPI has a separate tool which is part of Packet Maestro Pro. So we provide the flexibility of traffic analysis at a separate layer, and traffic routing and filtering at a separate layer. So DPI has its own separate tool which is sitting somewhere else, and it has its own CPU usage.
It will be innovation if they could forward the game.
Yeah.
Cool. Thanks a lot.
Thank
for
you.
the
Thank
great
you all.
talk. Thanks a lot, everyone.